start with company update.
So yeah, we've been working on the secret project for Comma. In the office, we have the secret picture of the secret project. Yeah, that's nice. I think we're a little bit behind right now on tiny box shipping. We'll definitely get those out this week. I think we have 3 pending orders right now. But yeah, we have a bunch. I don't know. We had some issues with bad CPUs, or something. I don't know. We do a lot of tests to make sure the PCIe comes up at 16x. Like there's a lot of things that can prevent the PCIe from being 16x. Loose cable, not seated in the GPU, bad CPU seating, bad motherboard. So we want to make sure that all the tiny boxes are really good before we ship them. Yeah. And since you guys have all been using the tiny boxes more in the tiny room, they're getting too hot in there. So I bought some fans, some HEPA filters, and we'll go in there with some duct tape and put it all together.
Yeah, it's okay. Use tiny box more.
Oh yeah, use it. Oh, by free. Oh yeah, by all means use it. It's not gonna break nothing. Right now we just have the windows open, which is fine, but I don't want to get dust in the room.
Okay. Sounds good. Rangerfly?
Yeah, so I think we're finally seeing some good progress on Rangerfy. I got the stuff merged yesterday to handle children in a coherent way. So this isn't a problem really when you're doing a top-down rewrite, but when you're doing a bottom-up rewrite, you can get to a node that has 2 children. And what usually happens, the bottom-up rewrite is basically DFS. So it will go through and it will process the parents before it processes like the other branch of the children, which is in most cases totally fine. Eventually, what happens is that the child branch just eventually gets processed. It sees that the parent was already rewritten and it grabs the parent from the cache. So it's not like it processes it twice or anything. But if you have a context, technically anytime you have a context for a rewrite, the cache can be wrong because the rewrite rule can be context dependent. So if the context changes, technically the cache is invalid, but it would be way too slow if we actually did that. So I found a better way to do this, which is you can raise an exception called rewrite not ready. So if you're on that path, if you're on like that path going through and you see that you're about to go to the parent node, you just raise rewrite not ready in the child, and then it will add that node to the back of the queue. So it'll process up the other thing, and that way you can like process both branches before you get back to the parent node. So this is needed for the flash attention fusion, where you want to make sure you've processed until you have both indexes ready, and then you can see what you have to close for the indexes. So that's one of the rules. And then I have 2 other rules. One is about closing ranges inside of... basically, the ranges have to be a tree. The ranges are not a DAG. Loops cannot be a DAG, because you can't have anything where you like reconnect them. You can't have diamonds, basically. So it has to be a tree. So one rule is dealing with that, and the other rule is dealing with... So convolutions, what happens is you have an axis that has 2 ranges. It's not having 2 ranges that's bad, but the 2 ranges are overlapping. So that overlapping is doing recomputation, and you just want to end that axis as soon as you see that there's recomputation about to be done. You don't have to, but like that's the heuristics that I'm trying to put in Rangerfy say do not do recomputation, basically. Yeah, so that's Rangerfy. There's a chance we'll get it merged this week. Maybe. I mean, there's a lot of stuff. I got to put tensor cores back, and I got to put optimizations back. But I think I have decent ways to do that. And this kind of rips out...
And you also need a new spec for specifying optimization for multi-reduce.
Yeah, so that one, the way that I'm dealing with is just going to be, it's going to just put all the axes in a list. And like right now, if you have multi-reduce, you say unroll 0, and you have like 2 reduces in parallel. Serial reduces already does this for, but if you have parallel reduces, that 0 will apply to both. But in the new case, it's just going to be a different axis. So it's a pretty simple spec.
Cool. Sounds good. Yeah, so next is llama. I post a new picture for what we have. So the place I put a date is I can train that thing so that the training loss reduced to 7 or something like that. So training is training.
We have to get to 5.6.
Yeah, it's 5.6 for eval loss.
Have we hit anything at 5.6?
Yes.
Oh, really?
If you train the 7 once for longer, the training loss hit 5.6, but that goes to my usual question for Wars Parrot that we want to see the correct eval script.
Yeah.
So-
This week I'll work on eval so that
Yes.
we can actually have.
Because
correct
now
eval.
it's sketchily fast how we hit 5.6. Because we train from like random weight, right? We are not even from like a pre-train weight.
Oh, not totally
So
random.
the other thing is our LR is very high.
No, but that's LR is okay. It's probably not a hyperparameter, but I don't think this benchmark is that bad.
Well, but we're not starting from random weights. We're starting from weights where we're just changing one layer, right?
For the 1B,
No,
no. For the
1B,
current thing we put, it's from random, right?
Oh. Seems like a bug.
Yeah, that's what I mean. So I posed the few thing I can think of. It's most likely we might have some issue in our thing, or our training loss and eval loss are very different. We are not actually training, or this benchmark is bad. So we want to rule out our fault first and decide. It's not like we will change anything, because for ML perf we cannot change learning rate for this one. We need to be exactly the same. So
Well, I mean, yeah, let's just get an eval up and check it. I mean, there's lots of things that can do this with training loss. Like, for example, say you're showing the same example over and over again.
yes,
Like, that'll get your training loss to do really well.
have even worse hypothesis, but okay. Yeah, so that's eval. But data loader seems fine.
It's good.
Model parallel. That I put the code in, and for 8B it seems to be correct, but for 70B on MI300X I got the compile error from ComGR. Yeah, from the compiler. So I'll find what's the problem with the kernel. I mean, those kernels are really big, so I'll find that and see what the issue is, and see if we need to update the compiler version or anything like that.
By model parallel, you mean you're putting a bunch of layers on?
Yeah, just
each?
split every layer on the A machine.
Yeah.
Have you tested if it works with LLVM? Because on MI300 it should work with LLVM, I think.
Oh, sure, I can test that. So I haven't really see what the error is. Okay, so that's what I will do. That also, it's either a compile. No, it's not compile. So I think scheduling or something around that is also very slow. But I will find a better repro before I complain too much. The last one is gradient accumulation memory. So gradient accumulation, I also put the code in. I stare for it for a while, and my expectation is if you increase the accumulation numbers, the input to the training function will proportionally be bigger, because now we are feeding like a bigger batch. But because internally for every mini batch, I realize all the gradients. So in my imagination, if we don't have lingering buffer and memory planner works correctly, it should not use more memory between mini batches inside that gradient step. But for now, I can see like not everything is free, and some like the memory usage increase if you increase gradient accumulation numbers.
Well, we should be like you should just be jitting one mini batch and then
No, that doesn't work.
why?
How does that work?
Jit one mini batch. Why?
Okay, then what's your training function? Do you jit that too?
On the outside?
Yeah. So we need realize to happen for forward and backward, right? So
Okay.
so that thing, if you want to jit, you need to jit together.
No, I wouldn't jit it together. So I would just jit like one mini batch forward backward, and have it store the
No,
gradients.
how do you have backward before in your mini batch?
What?
We are doing gradient accumulation.
Okay.
So what do you mean by backward?
Backward. Not optimizer, just backward.
Okay.
Okay, so you have a JIT,
Yes.
which does a forward and a backward.
Okay.
That's a mini batch.
Okay.
Then you call that JIT however many times you want a gradient to accumulate.
Okay.
You might have to pre-initialize the gradients outside of the JIT. You might have to do zeros contiguous on all the gradients.
Okay. So for every other stuff, it's not jitting.
What other stuff? Well, then you can JIT the optimizer separately. Right, then you just have a for loop in Python, which calls that JITted mini batch 100 times, or however many times we're calling it, and then you have another JITted thing that's the optimizer.
Okay. Yeah. Maybe.
Oh, yeah, no, whoa. It's going to take absolutely forever to schedule and stuff if you try to run all the mini batches and put that in one JIT.
Okay. Maybe that makes sense. That's just very hard to use.
Why?
Just hard to use. It's a bad user experience.
I think this is hard to use. I mean, you might want a helper function on the optimizer, which is actually zeros the gradients and creates those. I don't know exactly.
No, then how do you put the input to the mini batch? Anyway, there are hard to use part of this.
Unless I'm missing something, this doesn't seem that hard.
It's probably not hard. It's just annoying.
But
anyway.
Well, I'm not sure what you want it to be.
What do you mean?
You want to run all the mini batches inside of a single JIT?
Yeah.
I don't think
Is there a reason that wouldn't work? So for now it's working.
I mean, it would work. It'll just how many mini batches are we talking? If it's 2, sure, whatever, who cares? But if it's 100, it'll take forever.
For 405B, I think it's 1,000.
It's 1,100 or something.
Yeah, exactly. So we're definitely going to put that in an outer Python loop.
No. Okay, anyway.
But there's no way you can run 1,100 and ask it to schedule.
Not. They are all the same.
Yeah, but it doesn't know that.
Sure, I mean that's trading capability to user
I
experience.
mean, the real thing here is that it shouldn't be any of this. The real thing here is that it should be a range.
Yeah, but it's not going to be a range soon.
Yeah, but it's not going to be but no, I think for now, just.
Okay, I was thinking.
I'll write a simple example if I'm missing something about why this is hard. You are going to need one either helper function or a one-line for loop that actually creates the gradients as zeros.
Okay.
Because otherwise your first mini batch is different, right?
Yeah.
Which might even still work with the JIT. And the JIT's pretty good about that, the JIT.
Our JIT is very janky about weird.
No, but it won't capture. It won't capture the first run. It only captures the second run. It might just work.
Okay. You can write an example to your beautiful MNIST or something.
Yeah, you want a gradient accumulation example? What?
Yeah. Okay. But regardless, I'm still interested to know why the current implementation have memory issue, and that's the specific questions I post in Viz. If I think it's nice if our tools can show that.
It's probably because it's just not inserting contiguous as.
Yeah, I also want to know where.
In the gradients, right?
If I already realize all the gradients,
Oh, it's still doing it?
Yeah.
Oh, well, okay, that shouldn't happen. That's
Okay.
fine.
Anyway, yeah. So other stuff, I think people can talk when it's their term. Still want the faster MI thing, whether it's the AQL thing or AM driver or whatever. That. We have eval. Then we want this to work. For now, it's struggling if I have like a few millions of rewrites. And so I think I post the current thing that we have. So for anything 70B, I should get once I fix the compile issue, we should get the 512 one working. That one fits into memory. For anything with bigger context, we need the rectify or flash attention like stuff to start not creating too many contexts. Too many buffers with context square size. Yeah. So we'll see where we are. I also follow up with the 8B thing. So they are supposed to merge everything and have a documentation ready like last week, but it's not ready yet. So we'll see if we got that this week. And once that is ready, we should also prepare the data loader for that. And that one we should really be like training regardless of other optimization.
Do we know what the context size is?
A192.
Oh, wow.
But it uses the original llama tokenizer, so the vocab size is way larger.
Yeah, but we have fuse range or whatever. So I don't know. We'll see.
But that's crazy that they went from BERT and their replacement for BERT is an 8B with an 8192 context.
Yeah, because that's everyone using now. So
8192 context, really?
yeah.
I mean, A192 is small now.
Yeah. I don't know. Another thing that I'm interested in, maybe we can talk later, is multi-machine. So we previously say we want to try the multi-machine on BERT, but BERT is gone. So for 8B, I still want to see like a script or some easy to use thing that I can try like multi-machine BERT, training BERT. But we also, because our contract also has a multi-machine part, so for the AB we might as well just also run the 2-machine 8B on it and submit this wrong.
Yeah, Parrot, have you been following what UVN stuff is? I don't know why a kernel driver got involved. I think it's fine to just use the AMD.
Yeah, so supposedly the AMD thing had some bug, but I think he thinks it's just scheduling related. I think it hits the. Oh, he says that it hits the target if you just use the AMD driver.
Yeah, you want to test it and tell me when to pay out that bounty?
Yeah, I'll test it this week.
Okay. Yeah. So. Yeah. So I want to see some tutorial, easy to use or ready to pay for the cloud bounty, because we also need that for MLPerf. Yep. I think that's everything I have now, and we can move on to this.
I have a reapplication of Milton's original PR without all the behavior changes ready. Hopefully I'll merge that soon, maybe tonight, and clean that up. Basically, it's actually pretty good that it makes this for the CPU step a lot faster for the timelines of the kernels. Right now in master it's all fan, the for llama it will struggle a lot to zoom correctly. That should be fixed. I'm working on some refactors to make it nicer to look for 8 GPU runs. I think we optimize a lot for one device, but we should be able to support more use cases.
So is this perf just for the timeline view, or will it also be for the memory view?
It is just for the timeline view. I think we can genericize it at some point. Before like any generic shape.
Cool. Yeah, no, I mean, I don't want to add. I really didn't like the checkbox, whereas Like the problem with doing that is now no one's ever going to make this fast because it's behind a checkbox. But so it's still going to be slow because of the memory for now.
The checkbox exists, it's just default true.
Mm. Okay, the checkbox can exist for 6 days.
Okay.
But yeah, can like again, is there a fundamental reason why it's harder to make the memory fast, or you just need to do it?
I don't think so. I think it's gonna be the
I
same
mean,
thing.
it's n squared right now, and I think if we kind of want to draw like the same thing we draw right now, we can do better. I mean, we can also try to optimize, like not draw all buffers, but what's the reason for the such visualization? Like,
Yeah, I mean, if it's n squared, we got to just fix that. There's no reason that algorithm has to be n squared.
What algorithm?
Whatever we're using to draw the memory, like those.
All the stacking things?
Yeah. I don't even know how it's n squared.
Okay.
Okay, cool. Yeah, but no, it sounds like the stuff could be improved. I mean, you see, like the minute you put something behind a toggle, even if it's default true, it's like it's just an excuse to make it not performant. I don't know. We need to. There's lots of places in Tinygraph where this is bad. Like we need to move away in general from. Oh, just stick it behind an environment variable. Oh, it works some of the time. Oh, you just have to know. So. But cool. Good to see the performance stuff coming back. Yeah, and then optimizing for the thinking about the 8 GPU case. I wonder if we can have like a. Do we have like a mock 8 GPU thing, which will draw a viz for us? Like we have 8 null devices?
Yeah.
Null devices don't have timing, right? It's just instant.
You just don't have.
Wait, null devices totally have.
No. It's
Sure they
instant.
It's not instant. Nothing's instant.
I mean, like, I would have to put sleep in the call.
No, why are you putting sleep in the call? Well, it shouldn't be instant. Nothing is instant on a computer. How many nanoseconds is it?
It's not gonna be very informative, but okay, yeah. I mean, I
Well,
have
it's
like a real run on the AMD.
No, I mean, I agree that it totally, like, it's not like the null device is going to give you any sort of real stuff, but it should at least have some timing information.
Yeah, I think that's already working.
Is it? Let's see.
It's not, because null is not an HCQ device, and only HCQ devices are profiled.
Yeah, I don't see any kernels on the null timeline.
Yes.
Yeah, I mean, it's okay if you have to like zoom way in because it's only taking nanoseconds, but it's still going to take time.
That'll be HCQ.
Null should probably be an HCQ device, yeah. And everything should be an HCQ device, I think.
Then what's an HCQ device? Is it just not a device?
It's just a device, yeah, I think so. I think we got to get there eventually. But yeah, no. So I'm running with the null device has memory, but it doesn't have timings, and it should.
Okay.
Wait, but metal's not an HCQ device, and metal has timings.
I think Nemogen added the profiling for metal and HCQ.
See, yeah, now CPUs are HCQ devices. Okay, that makes sense. Yeah, I think null needs timing too. And then we can like test stuff with 8 GPUs pretty nicely.
Oh, and the Python marker idea is for because I want to plan a marker somewhere before to debug my grade ACC. So that should replace the usage of printing stuff in Python, then read the debug equals to log in between.
Do you want a marker or do you want like a width?
No, I want I don't know which one is better.
I think it'd be cool to have like a width. You could say like width, and then you put your training in a width, and you put your test in a width, and then it shows like training, test. Maybe we should support both, but I mean, the problem with just a marker is what's the start and stop? Like, we don't really have that.
No, but I would imagine marker is the primitive you want, and your width is just plugged into markers, something like that.
How is this stuff done now? Do we have like a start and an end, or do we have?
Oh, we don't have this. I just print.
No, I know, but I'm saying like in general, like how are most things tracked?
Most things have a start and end, yeah. It's a range.
And they have the start and the end in a single. Like, do we have any sort of infrastructure that looks like a marker at a single point?
We can just create an event that
No.
starts and ends are the same.
We do for the buffer allocation and deallocation, those are point events.
Those are point events. Okay. And then do
But
we have
they are
anything?
like that? Like I would imagine, Jenny, you wanted horizontal line on the like timeline, right? Or sorry, like a vertical line on like the entire span of the
Yes.
screen, like a
Yes.
red line with like a
Which
2
I mean-
pixel.
So
width.
say if my thing somewhere here,
Yeah.
I put events, and I want a line like this.
Oh, you want a whole big vertical line.
So I know at that point what happened on every device.
Oh.
Because for now you see like memory use increase, but you don't know like which part of a Python is increasing.
I see.
Yes.
Okay. Yeah. How much effort will this be?
No, a lot. I'll add it.
Cool. Yeah, I like kind of both things. I like kind of the. I mean, also we should think about how we can track these things back to like the Python. Like especially with this event thing, it'd be cool if it just said, "Oh, here's the, the file and line number." With like I don't know if we have like universal infrastructure for like the VS Code links. I've never used it, but okay, cool. So you want like a whole line from all the way, a whole vertical
Yeah,
line.
basically a way for me to. It's like debugger. Like you advance, and you stop somewhere and see, okay, what's the buffer on every.
Yeah, you're looking at that line and you're seeing what's allocated and stuff. Yeah, cool.
Okay.
We mentioned SQTT too. I did some work on just decoding it. So right now the status is that it can decode the raw stuff. I have a feeling that they're gonna open source the other decoder that's closed source. I didn't spend time reverse engineering it. But yeah.
I really can ask. Write up at AMD hardware what you want open source, and I'll forward that to our contacts at AMD. Also the things where it's like, wait, so you're talking about this RockProf trace decoder that's not open source?
Yeah.
Wait, what? It's closed source and they just have an SO file?
Yeah. I know, it's absurd. And it doesn't require any raw chem install to run it.
I
It's
see.
like
So
a
this is the thing you want open source. All right, cool. I'll post that on Twitter. We'll see.
That's the only thing that's like I'm fetching.
Yeah. Yeah, I see. So like what's the API to this thing? It's just an SO file. It doesn't even have a header.
Nothing.
Where's this tool that they're talking about? Oh, it's a plugin library for the Rock Profiler SDK, which is retired. We should use the Rock M Systems repository. Okay.
It's a nightmare to figure all this out. But yeah, I mean it works. And it's correct, I assume. I mean, like I this burn cycles and it looks correct.
Cool. Yeah, and then I see that in the disassembler you're using Co-Manager. Any reason to use Co-Manager and not LVM?
LVM errors out. Like the LVM has 4 different disassembly APIs. I'll try more. I'll try harder. But yeah.
I mean, you can also like Co-Manager's open
Data.
source. You can read whatever it's calling into.
Yeah. I don't know. I'll see. Yeah.
I mean, there's kind of a question here about like we might want to start thinking about doing our own.
Disassemble.
Well, not really a disassembler, but like kind of like a something that'll like, because eventually we're going to want assembly output from these things. So we don't want a disassembler. We want something that can like a Python representation of each of these things, and sure, one of them's a print, and that just happens to be a disassembler. I don't know. No, I don't think we should think about this yet. Yeah, I'll ask AMD if they can open source that. But then, like the stuff you're writing, is it? You're also. I see that you have these things that say you're taking from these header files. Is there any reason we're not just using the ctypes lib on the header files?
Rawchem hasn't yet shipped those headers.
Well, that's okay. You can put the headers in extra.
Oh, I see. Okay, yeah.
Yeah. Put the headers in extra, and then use ctype libs instead of like manually creating these things.
I see. Yeah, that's fine.
Yeah, it doesn't matter where they are. I'm okay with sticking headers in extra and just generating from them.
Oh, okay.
Cool. But yeah, top priority is Viz performance, Viz features. It's kind of where we are. And then yeah, second priority is getting into the micro scheduling.
Okay. Next, drivers.
Yeah, so so for the CPU and the llama floating thing, I just get my eyes on the profile, and actually the whole speed was the whole speed. I mean, the whole time we just spent in just CPU kernels. So they currently overlapped. I mean, the transfers overlapped with the kernels on the GPU, so that looks fine. But yeah, CPU takes a lot. So the next thing is threading.
Is actual
I
threading on the
think,
CPU.
yeah, I think we should use several threads. So just to speed up the CPU kernels.
Yeah, I mean, I think there's no way. I think you're limited to something like 16 gigs a second if you're on a single thread. I wonder what memory throughput you're getting. Maybe.
Yeah, should be around that.
Yeah. But yeah, no, we got tons of thread potential there. How's the AM MI300 coming?
It's like everything up to GFX is ready. I mean, the PSP and the firmware stuff. So yeah, the next thing is GFX.
Cool.
Yeah.
And yeah, then how about the fast sync?
Yeah, I mean, I actually haven't like seen any disassembler, but both of you, yeah, I can do AQL. I mean, yeah, as I've said, we're gonna have some problems with the synchronization because AQL has only one way to synchronize. It's just the atomic decrement. While we just use.
Well,
So yeah, but yeah, we can.
AQL has
Yeah,
a PM4 backdoor you can use.
Yeah.
I think that might
Yeah,
be.
I hope that's fast. Yeah.
Yeah, I think it'll be fast. I've read the code for it, and it's very short. That the AQL backdoor. The problem, the thing that we can't do with PM4 is like the code to launch the kernel and synchronize the kernel is all in this one big AQL method. But yeah, I think for our normal synchronization, like our between GPU synchronization, we could just use the PM4 backdoor and it'll be fast.
Yeah, and also another thing, I'm not sure. I don't remember any method or any packet in AQL to execute indirect buffers, and that could cost us a loss on the CPU speed. We can just execute indirect buffers.
Yeah.
And I don't remember any of these.
Well, I mean, eventually with the CPU speed, I think we have to start like moving these drivers to Tinygrad themselves, and then it'll just compile a Clang program to quickly set whatever you want to set.
Yeah. Mm, yeah, maybe this works. I don't know. Yeah.
Yeah, I mean that's been my dream for the drivers for a while. Like to the point that the drivers are actually written in Tinygrad. The MMIO is tensors, and yeah. No, I think one of the things we'll work through in Hong Kong is I think one of the goals for Hong Kong is merging device and HCQ device and thinking about like which of these things we can unify into a smaller set of primitive abstractions. But yeah, for now,
Yeah, I think actually, yeah, I thought about that. Yeah, I think GPU backend is the one is the hardest to adopt for the HCQ.
Wait, sorry,
But yeah,
say
okay,
that again.
I'll figure it out. I mean the GPU backend, it doesn't follow the rules which are in HCQ right now. So, yeah, but
The
yeah,
GPU
that's a
like
task for the
OpenCL.
future. Yeah, the GPU backend.
Yeah. I mean, OpenCL has this other problem with the sub buffers are annoying. I mean, there's a reason no one likes OpenCL. But cool. Yeah. I think per for the CPU
so-
offloading and getting rid of that. It's like 10. It's like 10 microseconds. It seems like for kernel synchronization.
Yeah, that seems. I mean, that seems a lot, but
Yeah, I mean it's a full atomic to memory. It's a lot better than it was, but still, I think we got to go to the AQL thing is using like this secret. There's like a bunch of like secret MMIO on the mechs that synchronize them all, and the quickest way to do this is just use AQL. I mean, then also the advantage to using AQL is we can start like we can make it a perfect copy of what HIP is doing. And I will continue to prod AMD and tell them AQL is stupid.
yeah, okay. So yeah, going to finish AM, then AQL I think is faster to implement, and then CPU loading.
Cool.
Next is cloud, or whatever Worsberry wants to add.
I mean, I've mainly been doing MLPerf stuff, so I guess the only thing for cloud is I'll test out all the multi-machine stuff and see if it's good.
Sounds good.
Yeah, and just let George know when it's ready to pay the bounty and have the script so that we can reproduce the multi-machine bird round, for example.
Yep.
Okay. Symbolic or anything from seats.
Hi, can you hear me?
A little bit of background noise, but yeah, I can hear.
Okay. So I fixed a bug in the Z3 render where it's like if you're doing a floating point load, casting that to an int and then using that in the index, that was giving problems. So that fixed part of the hang that you posted an issue about, Genu. Z3 is still hanging somewhere else in the beam search, and this time it's not an exception that it's throwing. And it's only hanging if you do parallel equals greater than 0. So I'm still trying to get to the bottom of that. It's... Sorry?
Parallel should be multi-process. It should be.
Yeah, that's also... Well, I mean...
Well, no, I mean libraries can be not thread safe, but I don't know a library that's not process safe. Maybe it's an initialization issue.
Yeah, I'm not sure.
But yeah, no, I saw we have comp EQ now.
Yeah, kernel's looking more nicer. Also, like most of the more equal to 1 stuff is gone.
Cool.
And the div and not folding factor is almost done.
Great. Yeah,
Yeah.
I think we always have some subtle bugs in there. Hopefully they're gone now.
Yeah, so I tried and remove, like, there's a flag, so there's the correct div and not folding flag. And it's a bit more annoying, I thought, because there's something in OpenPilot that really expects division and modules to be like floor division, and if I remove that flag, then so basically the flag causes division to be rewritten using floor div rules, which is not always the same if the numerator is negative. But it like really needs it for correctness. I thought it was just it needed to simplify the gates, but it was actually like producing different results if I correctly simplify it using C, which is a bit weird.
So not entirely sure what that is, but I think the general principle for dealing with OpenPilot is you have enough thing on benchmark, and any rewrite you want to test, or we have a lot of like image related rules. It's fine if the kernel number or read image, write image, load counts are slightly off. I think as long as the ones that run on benchmark is similar speed, it's okay to change.
I mean, the problem it goes from like 20 gated loads to like 120. And then, so I mean, I try to use like the simplifications for the gates also become quite tricky because you have to do like all the simplex we do now is you have a plus b together is greater than 0. So either a or b is greater than 0, but then there's also gates which have is greater than 2 or greater than 3. So then you have to try like
Yes, I remember.
1 equals it like really blows up. So those gates are really hard to simplify with the method we use currently. So I wrote a Z3 gate simplifier, but then that also caused incorrectness because of the CDIF thing.
Yeah, so I think I cannot give you like specific suggestions now because I think there are multiple issues here, but again, I think the general idea is OpenPilot speed is important, and a lot of simplification rules is built for that. And we want that to be correct, of course. I think maybe some of it for now is practically correct. Like
The annoying thing is that the incorrect rule is also causing it to be faster, which I mean, I think the easiest way to fix it might be like, I mean, I still want to change iDiv to be floor div at some point, but then I need to work on the the fast iDiv. I need that to be complete.
Okay.
Because otherwise it's going to be hard.
Yeah, I think this is probably better discussed somewhere in PR or issue. If you need to take a look, just let me know. But high level thing, as I said, is we need to keep OpenPilot fast because now they are like weekly using the latest. We don't want to block them from upgrading any grade. But aside from that, do the correct thing, do the simplification. Those are good.
I have one other like symbolic project to think about. You got to get a different get a different mic for next week too, because you're constantly echoing and on right now.
Okay, sorry.
Yeah, you're good. But the other project is, so right now we have logic in reshape, in view to merge reshape. I want to delete view entirely. So do you know where those tests are? Can you? Where the current symbolic can't do the same things the view reshape can do?
Oh yeah. Like canonical-wise password or something?
Yeah.
Connect like shape checker or something like that?
I think this is we gotta upgrade symbolic to pass all these tests. Because Rangeify is gonna delete view.
Yeah. Yeah, I mean, I know a couple of rules that are missing.
But yeah, I mean,
Right.
you see what I'm talking about the like the reshape, all that
Yeah, I know.
logic given view should be symbolic. Yeah.
Yeah.
Then the other thing is that you might run into problems with is right now we have vmin and vmax, and if vmin and vmax, if it can't simplify, if you have something that's basically like define var a minus a, that may not have the right range. You know, this one with, like right now, vmin and vmax are returning an int and not a uop, and that might be something that they want to change.
Yeah.
But A minus A is something else, so it's not about you having a rank, but it's like the same thing. So if you have A that's ranks from 0 to 5, and you have B that's from 0 to 5, then A minus B obviously shouldn't cancel out.
Yeah.
But A minus A should cancel out.
Well, a minus a can cancel out, but you can have a bunch of. All right, you gotta your microphone is actually real bad, dude.
Okay. Anyway. Okay.
Yeah. So. Sure, if you just have a minus a, that should cancel out.
Uh-huh.
But sometimes you can have like, say you have like a plus 3 minus a. I mean, right?
That's a different problem. That's the an add group of add that should cancel out each other.
Yeah, I mean, yeah. One way to decide, yeah.
Changing the vmin vmax won't solve the case for a plus 3 minus a should be 3.
Why wouldn't changing vmin and vmax solve that?
How? It's not a min-max problem. It's because A should cancel out with A, right? Now you replace A with B with the same min and max. It shouldn't cancel out.
Well, yeah, I know, but I'm saying, okay, so like if you have it for, if you ask it what the min is of A plus B, A plus 3, you can say that the min is A plus 3 and the max is A plus 3, right? Maybe it doesn't work.
No.
Yeah. I don't know. This is hard to think about, but
okay. Anyway.
Yeah. Anyway, we should make sure that we're dealing with all those cases too. Maybe it's actually just through simplification, and we have to look at ad chains better and stuff.
Yeah. Okay. And change your microphone. Okay. Next. Next. I think. Yeah, we are waiting for some stuff. So we have a branch for Comma people to test their new OpenPilot model with if op support and cubic support. I just merged the cubic implementation in Tinycorp proper, and we would do the refactor first before we merge the if support, because if support otherwise it's a little bit hacky and we don't want that. And there are segfault issue that seems to be related to metadata.
Well, is it metadata? I think it's gotta be like disk, because the ResNet does it too, and I just looked, and ResNet's not using Onyx.
Maybe it's a different one. I don't know.
It seems like the same one. It seems like something broke in disk. I don't know. This segfault's been here for a long time. I can't reproduce it locally. I've tried.
Okay. Anyway,
I don't know. Should I just spend a couple hours on this? Because that segfault's existed forever.
sure. If you want to. Spend
Hey, I have
some
a
time to
call
fix
down
it.
for the segment fault.
Oh, you have an idea what it is?
No. I have an issue about this, and it's not seems a disk bug.
It's not a disk bug, you don't think?
Yes. I not remember clear, but I can see the segment for the trace back. You can find the issue.
Oh, the issue says it might be CPython bug.
I mean, you have some crash dumps, of course, to look into. Can you report?
There is a link to a gist. I can't report it local. I was reproduced it on a Linux machine to run the script multi times.
I mean, it sure does look okay. Those do look metadata related. It's in wrapper.
Everything goes through wrapper.
No, I know, but it's in wrapper.
Okay.
Test well. Do you see the traceback?
Yeah, I see the traceback. I see them both being in wrapper. Oh, here you got a GDB traceback. Okay, let's see.
Yes.
pthread bullshit. Metadata set. Okay. Yeah, I don't know. I mean, do we have to use this context vars thing?
Yeah, should be thread safe. If we use this correctly, it could be a Python bug.
Yeah, I'm just. I mean, one idea to kind of fix this is I see us using this context vars thing that I don't know much about. I think it's the only place we use it. Do we need it? Yeah, I mean, maybe we can just refactor this to use like less. I could totally see the internal implementation of this context var thing not being like thread safe or something.
Okay. Maybe we follow up this in some discussion thread
Yeah, but cool. No, it's good to have this.
and get this fixed. Yeah. So otherwise, I think on X is progressing fine. Should be there soon. Okay. Other bounties. Oh, I spent some time reading our MOE stuff. I think there are a lot to be gained from the sorts and the top K specific implementation. So for now, the parts that we select top 8 from just 64 values takes a very, very long time and lots of kernels. So for
Do you want me to look at a Rangeify top K and see what it'll generate?
what's the Rangeify top K?
I'll put top K through Rangeify and see what it fuses. I mean, it's just I've seen how many kernels top K is. It's absurd.
Yeah, you can try that. Sure. I think I tried to put fuse somewhere in that block and my machine hand. So
I see. Well, ready for yeah.
Range find
Fuse is
may
bad, fuse is
help. Yeah.
bad,
Okay.
yeah.
Great. Yeah. So I think fixing that should be fairly close to the OMOE bounty, and it should be helpful for anyone who is doing the GPT OSS. But
I'll look at Top K and Rangerfire and see if the pattern just kind of comes out nice.
yeah, we also use a very clever trick to flip the comparison order so that it's all the same.
Wait, what do you mean?
So sort, go up, yes. So if you look at this picture, that's your Vitonic sort picture.
I don't know what that is.
It's basically the order you need to compare stuff and put the bigger one in one direction and small one another.
Yeah.
But you have the blue box and green box. Those are comparing in different directions. So
Okay.
So the trick we did in sort is you flip all the green box first, so you only compare one direction, then you flip it back.
Should mostly be fine. I mean, we have some problems with cat. Like, we have some problems in general with
Yeah, so cat is another problem.
yeah.
Cat is more similar to a problem for the slice assign.
Yeah, I can. I'll look into these patterns with Rangerfy and make sure we're getting them.
Sure.
Yeah. Hopefully, this stuff should just be free.
Great. Okay. What other bounties? Do you have anything? What?
Well, the big one is the GBT OSS bounty.
Who's going to do that?
I don't know. Someone in here.
Oh, can we have the WAN 2.2 bounty?
Which one?
WAN? WAN? That's the image to video model that's supposedly to be very good.
Oh, I never heard of this. Yeah. How much should we offer for it?
I don't know how hard it is. The model also supposedly should work in like 8 gig VRAM or 16 gig VRAM, something like that.
Mixture of experts? Wow, we really need to just work on our mixture of expert stuff. I don't know. Maybe we should just have it just... Let's get this one first.
Okay.
Hopefully there's... I think there's progress on the Thunderbolt thing. That guy's still been posted on Twitter.
Oh, I thought he stopped. No?
No, he's still working.
Okay. Great. Wolf's Parrot, can you find a way to merge Muon?
Okay.
Okay.
Oh, yeah, I think it's mostly good, yeah.
Yeah, just do a final like style check or any nitpick thing you have.
Yep.
But otherwise, it should be fine.
Yeah, I'll just merge it. If it's good.
Cool. Yeah. Anything else?
Oh, the reduce axis bounty is ready for review now.
Oh, cool. Yeah, I will try to get to that today.
And I found that after this PR, the multi-tensor test fails, just like the master one. It looks like a meta scene bug.
Yeah, but that's only on Metal, right?
Yeah,
Yeah,
I
Metal has...
put a sign dev synchronize at the end of the transfer function. This will be fixed. Not sure it's the right fix.
Yeah, okay. I'll look over the reduce axis thing. If that bug's unrelated, then we'll just merge it and disable the test for now. Cool.
Okay.
Yep. Cool. I'll review that today.
Great. Okay, I think that's everything for this meeting. Thank you, everyone. See you next week.
Bye.